This video is intended to supplement the study of microeconomics and the concept of elasticity. Some have argued that consumers don't vary the quantity of gasoline they will buy when prices change. This is because the number of miles they routinely need to drive is relatively constant. During May 2011, the average price of gasoline was $3.76. U.S. consumers bought about 5% less gasoline than during May 2010, when the average price of gasoline had been $2.79 per gallon. In 2014, the price of gasoline averaged $3.36, and in 2015, the retail price has been as low as $1.59 per gallon, showing the great variability in prices of gasoline. Consumers did find ways to cut back the quantity of gasoline they purchased when prices were relatively high, but how do we account for only a 5% reduction in the quantity purchased when the price increased by nearly 30%? People do respond to both positive and negative incentives, but in varying ways. The law of demand states that consumers will respond to price decreases by buying more of a product, ceteris paribus, but it does not tell us how much more they will buy. The degree of responsiveness or sensitivity of consumers to a change in price is measured by the concept of price elasticity of demand. If demand is elastic, there is a large change in quantity demanded, even when price changes by a small amount. When demand is inelastic, there is a very small change in quantity demanded, even when there is a large change in price. The quantitative measure of elasticity is shown in this equation, where the coefficient for the elasticity of demand, shown by E with a subscript D for elasticity of demand, is equal to the percent change in quantity divided by the percent change in price. Here the numerator identifies how much more or how much less of a certain product consumers will buy given a price change shown in the denominator. The same relationship can be shown using the midpoint formula, where we determine the average of the change in quantity using the initial and final quantities and the average change in initial and final prices. We employ the midpoint formula to obtain the same coefficient of elasticity of demand, regardless of whether the price change we analyze changes up or changes down. The midpoint formula calculates the average percent change for both quantity and price using the initial and final quantities and the initial and final prices. When the elasticity coefficient is greater than 1, it means that percent change in quantity demanded is greater than the percent change in price. So demand is elastic. When the elasticity coefficient is less than 1, the percentage change in quantity demanded is less than the percent change in price, indicating that consumers are not very sensitive to changes in prices. When the elasticity coefficient is equal to 1, this is a special case called unit elasticity. This means that percent change in price and percent change in quantity are exactly the same. And perfect inelastic demand means that consumers will buy exactly the same amount no matter how high or how low the price is. Perfect elastic demand means that nothing will be purchased if there is any deviation from the current price. Suppose that you own a service station and you are currently able to sell 2,000 gallons of gasoline per day for $3.50 per gallon. You are considering cutting the price to $3.30 to attract buyers who have been buying their gas at competing stations. Use the midpoint formula to calculate the price elasticity between these two prices and the resulting quantities that each price yields. Stop the video. Calculate the price elasticity of demand. To complete this calculation, we want to first look at the percent change in quantity. To do this, we look at the two quantities, 2,500 and 2,000, and take the absolute difference, which is 500. Next, we want to take a look at the average quantity. The average quantity is determined by adding 2,500 and 2,000 and dividing that by 2. In this case, we have 500 divided by 2,250 to come up with 0.222. Next, we want to take a look at the change in price. Here we have an absolute change in price of $3.30 and $3.50. The absolute change is 20 cents. Next, we want to look at the average price. To obtain the average price, we add $3.30 and $3.50 and divide that by 2. When we look at the equation for the denominator, we look at 20 cents divided by $3.40 to obtain 0.0588. To determine the price elasticity of demand, we take our denominator and divide that into our numerator. In this case, it's the 0.222 divided by the 0.0588 to come up with a coefficient for the elasticity of demand of 3.77. Note that the numeric value of the coefficient is greater than 1. Next, take a look at a little bit different scenario. In this case, suppose now that you are only able to sell 2,100 gallons of gasoline per day for $3.30. Use the midpoint formula to calculate the price elasticity between these two prices. Stop the video, and when you've completed the calculation, turn it back on. In this scenario, we'll go through the same steps. First, we'll calculate the percent change in quantity. In this case, we're looking at a difference between 2,100 gallons and 2,000 gallons, and divide that by 2,100 gallons plus 2,000 gallons divided by 2. This is our numerator in our price elasticity of demand calculation. Next, we want to take a look at the change in price. In this case, everything stays exactly the same. We're still looking at a price change between $3.50 per gallon and $3.30 a gallon. So our denominator stays the same at 0.0588. Our price elasticity of demand now is 0.833. Note here that the numeric value of the coefficient is less than 1. Some of the extreme cases that we mentioned before. When we look at perfect inelastic demand, we'll show a demand curve that is perfectly vertical. The demand curve would be vertical and graphed as a parallel line to the vertical axis. The elastic coefficient is 0. An example of a perfectly inelastic demand might be a diabetic's demand for insulin. The other extreme example is perfectly elastic demand, in which a small price reduction would cause buyers to increase their purchase from 0 to all that is possible to obtain. The elastic coefficient is infinite. An example of a perfectly elastic demand is a firm's demand curve for a purely competitive industry who is unable to change that price. The total revenue test is the easiest way to judge whether demand is elastic or inelastic. This test can be used in place of the elasticity formula unless there is a need to determine the exact elasticity coefficient. The total revenue test is important to understand the relationship between price elasticity and total revenue. Demand is inelastic if a decrease in price results in a fall in total revenue, or an increase in price results in a rise in total revenue. Demand is elastic if a decrease in price results in a rise in total revenue, or if an increase in price results in a decline in total revenue. Demand is unit elastic if total revenue does not change when price changes. In this case, we can see that as price moves from A to B, total revenue moves from $20 to $40. A decrease in price resulted in an increase in total revenue. In this case, we can see that a price change from C to D, from $4 to $1, results in a reduction in revenue. In this case, we can see that reducing the price from $4 to $1 resulted in a decrease in total revenue. Notice that in the high price region, demand for movie tickets is elastic and revenues increase as prices fall. Midway through this schedule, however, movie ticket is unit elastic and revenues stay the same as price changes. In the low price region, however, elasticities of demand are inelastic, and as revenues fall, the price also falls. We can show the same chart graphically. In this case, we see that in the higher priced region, we have elastic demand. As the price changes from $6 to $5, however, we see unit elastic demand. And in the lower price area, we see that we have inelastic demand. So what are the determinants of elasticity? First, substitutes. With more substitutes available, consumers have more alternative options. So when there is a change in price, there is a greater percentage change in quantity demanded, making the demand more elastic. The broader the definition of market, the more elastic the demand. The greater the proportion of income needed to buy the good, the more elastic demand will be. Consumers will be more sensitive to changes in prices because the price change can result in thousands of dollars difference. Some luxuries are goods that consumers can go without. They will change the amount they purchase by a greater amount, even if the price change is a small amount. Time is another factor. It takes time to alter the amount being purchased for some goods, so the more time available, the more elastic demand will be. A person doing their Christmas shopping on Christmas Eve has very inelastic demand because he or she doesn't have the time to look around for alternative purchases. Some of the elasticities of goods in this table are surprising. Use the determinants of demand to discuss why Major League Baseball tickets are not inelastic, but they are more inelastic than gasoline. What makes newspapers, movies, and beer inelastic?